Good afternoon. We are the group number 3. Be Daniel Moran Torres, Yesenia Zenet Bolaños, Doncel, Ángel Gabriel Gil Carrillo, and Jose Giovanni Temich Cantero. Okay, next, please. Okay, today I am going to talk about the theory of constraints and some of its key concepts in production management. The upkit is presentation is explain how real production system work, especially when there are limitations or difference in capacity between process. In this project, he analyzes concepts such as unbalanced capacity, bottleneck needs, and systems efficiency, using a comparative table to make the information easy to understand. The theory of next, please. Okay, now the theory of constraints is a management approach that focus on identifying the main limitation of constraints that after the performance of systems. According to this theory, every system has a list of constraint and improve the intersystems in depth of training the optimists our process. The focus is on the most critical part. In reproductions systems, process does not work and same speed. There's no balanced capacities where some processes are faster and others are slower. This situation creates bottlenecks with process with the lowest capacity and limit the overall system performance. Although balance capacity may seem ideal, is it now realized unbalanced capacity is the basis of theory of constraints. Goldron also explains that the goal of company is to make money now and the in T4 to 8 chips. This company is more focused in increasing turn, reducing inventory, and controlling operations expensive. This means that success is not about keeping our resources busy and about improving the performance of the systems, inter-systems. Um, Productivity in context is not about production more units, but about generating more value. A system is productive when in decreasing wheel production and operating costs. Growth also posted some rules for scaling production. For example, the capacity of system depends on bottlenecks. Time lost is the bottleneck affects the entire systems and production moves and synchronization with the principal help improve efficiencies and reduce waste. Um, From my point of view, the theory constraints is very useful because it's real solution in companies. I believe that focusing on the bottlenecks is more effective. The trying to make our process equal. This approach help improve decision making and increasing productivity. Okay. Next, please. Now I will explain the differences between balanced capacity and unbalanced capacity. Balanced capacity means that our process have the same products, right? In the in theory, this created a constant and uniform production flow. However, this is solution is not very common in life. On the other hand, unbalanced capacity, of course, when processes have different production rates, this theory regular is an cause of inventory release. In this case, bottlenecks happen. Bottleneck is the process with me lowest capacity, and I limit the system's performance. Where balanced capacity is more theoretical, unbalanced is more realist, and is the basis of third country. Next, please. Okay, from my point of view, unbalanced capacity is a very important causes reflect that really happenings in companies. Instead of treat the microprocessor queue, is it more effective to identify the bottlenecks and improve it. Ability to use approach helps companies make the better decision and improve productivity because it focuses on the most critical part of the system. In conclusion, in understanding imbalance capacity is keys to management production systems in more efficient and realistic way. Okay, is all.
Hello, my name is Jazz Sania, and today is what told avoid the fucking tokens, the definition ever, the stacing fable y water and capacity construction de ratio. Concept, tenemos a depend ever, su definición es where the events that affect another, for example, is the thank you card with the replenishment the probability chance. And en static deflation and concept, en static compression and round the chance and die for example, salgo on the dough. Next, please. And opinion in thank you is important the because no the chance in the R manifold the summiting is a hundreds. Siguiente, please. En concept, what the neck uploaded is a word process from the web, for example, action machine. En capacity consume the resource, turns are the resource with limited capacity. For example, a word with limited thank you. Next, please. My main opinion in the field of phone is a very important vouch. It's a hills. Helps increase Bluetooth and reduce costs. In conclusion, the concept help a make water decision. Thank you for attention.
Okay, good afternoon, everyone. Today I'm going to talk about the evolution of production systems and how we manage them, starting with the basic elements for construction in manufacturing. As you can see in this comparison table, there is a clear evolution from traditional to modern manufacturing. Traditional systems relied heavily on conventional raw materials, but basic mechanical equipment and a high dependence on manual work. However, modern manufacturing has completely transformed these processes. We now use advanced materials such as polymers and smart materials and rely on greater automations through CNC machines and industrial robots. Furthermore, technology is no longer limited. It integrates IoT, I, and CAD/CAM systems. This shift allows us to move from manual inspections at the end of the line to real-time quality control monitoring with sensors. From my perspective, the integration of automation and data analytics enhances efficiency, reduces errors, and increases competitiveness in global markets. More importantly, combining technological efficiency with skilled labor allows for a gradual transition toward Industry 4.0 one, while maintaining operational stability. Now, moving on to how we manage and optimize these complex environments, let's look at the control methods in TOC, Theory of Constraints. This table outlines the primary control methods to maximize our system throughput. We start by analyzing the time components, breaking down total production time into processing, waiting, and idle time to identify inefficiencies. The core of this theory is bottleneck identification. We must detect the specific resource that limit our overall system capacity. Once identified, we apply time-saving methods using lean technologies to reduce non-value activities. It is also crucial to avoid shifting bottlenecks. We must prevent moving work to non-constrained resources, which make appear free but actually create systems imbalances and overproduction. To maintain stability, we implement the drum buffer rule (DBR) system. This synchronizes the production flow based on the bottleneck in the drum and protects it with a buffer and controls the material input with the rope. To conclude, what stands out is that unlike traditional efficiency models that try to optimize every part of the system, TOC prioritizes system-wide optimization over local efficiency. This is critical in real-world manufacturing environments, where improving a non-bottleneck resource does not necessarily increase overall output. Thank you for your attention.
Hello, my name is Angel Gabriel. This table illustrates how quality impacts the four pillars of the theory of contrast. Operating expense. A defect at a bottleneck isn't just lost material, it's lost revenue for the entire plant. Batch size. Smaller batches provide fastest feedback, allowing us to catch errors before they become mass production failures. Inventory wipe. High inventory levels hide quality problems. Lowering wipe makes defects immediately visible so they can be fixed. Throughput. Quality is the ultimate throughput killer. Every defective part directly reduces the plant's finally out output and its ability to generate money. Next, please. In my opinion, quality in top is a strategy to protect the floor. The most critical takeaway is that a defect at bottleneck costs the entire brand's renew. Therefore, reducing batch size is essential to catch errors early and prevent them from turning in expensive wasted inventory. Next, please. Bob. In summary, quality stock is not just a technical standard, but a flow strategy. We have seen that error at the bottleneck doesn't just cost red materials. It costs the profitability of the entire plant. Tier 4 decay is the reduced batch size to detect failures early and lower inventory levels, which makes quality issues visible immediately. In conclusion, a thorough competitive advantage is achieved by optimizing the global system rather than local efficiencies. By predicting or converting with preventive quality controls, we ensure a steady flow that meets market demand without compromising operating expense. Um, Thank you.